So if you watched the last video, you know how I took cosine of 3t equals 1/2 and got to this solution over here. And then how I took this solution and turned it into one full expression. And that was for the express purpose of trying to find only angles that were between 0 and 2 pi. And the nice thing about having expressions that are all one fraction is it makes my job very easy. Basically, what I need to do is take different values of n, like n equals 0, n equals 1, n equals 2, and keep plugging them into these different expressions until I'm outside that 0 to 2 pi range. And the other thing is, like, we took the time to make it all one big fraction. That makes this job way, way easier. So if I let n equal 0, for instance, and I plug 0 in for n right here, I get my first answer of just plain old pi over 9. Yay. If I add another 1, if I let n equal 1, I'm going to get pi plus 6 pi over 9, which is 7 pi over 9. So that'll be another answer. If I let n equal 2, I'm going to get pi plus 12 pi all over 9, which would be basic math, 13 pi over 9. If I let n equal 3, I'm going to get pi plus 6 times 3 is 18, 18 pi all over 9, which ends up being 19 pi over 9. And actually, now I know that I'm outside of the 2 pi range. And the way I know that is as soon as the coefficient in the numerator is more than twice as big as the denominator, I've fallen out of that 2 pi range. So I'm not going to include this answer. So this part of the solution gives me the answers pi over 9, 7 pi over 9, and 13 pi over 9. But there's something else that I really want to point out, because I don't need to do this whole brute force thing of plugging in these n's every single time. I don't need to do that. Because I wrote this as one single expression, if you look at these values, I hope you can see a pattern. If I'm going from pi over 9 to 7 pi over 9 to 13 pi over 9, what's happening with those numerators? Do you see what's happening? What do you notice? It goes from 1 to 7 to 13. It goes up by 6 every single time. That's the advantage of taking the gross expression here and rewriting it all as one fraction, is I can start with whatever they're starting me with, and I can just continually add 6 pi to my numerator. And I'm going to do that until the coefficient on pi is more than twice as big as the denominator. So there's a second set of solutions that comes from this 5 pi over 9 deal. So I'm going to kick it off with 5 pi over 9. And then I'm just going to continually add 6 pi to my numerator until it's more than twice as big. So now would be a great time for you to pause your video and see if you and I get the exact same answers. So go ahead and pause it now. And now that you've resumed it, hopefully we agree that it'll be 5 pi. I'll add another 6 pi to 5, 11 pi over 9, add another 6, 17 pi over 9. And if I add another 6 to get, it'll definitely be bigger than twice the denominator, right? So this is it. Like, this is still less than 2 pi because 17 is less than twice the denominator. Twice the denominator is 18 pi. It's 18. So as soon as I get a number on pi that goes above 18, I'm done. So these are all of my answers between 0 and 2 pi. Pi over 9, 7 pi over 9, 13 pi over 9, 5 pi over 9, so on and so forth. The last thing I want to say in this video is this maneuver that we used here, I only bother with this maneuver when I'm specifically asked to get answers between 0 and 2 pi. I wouldn't bother doing this if this hadn't been part of the instructions. If you're only asked to find all real solutions and you get to here and you stop, fantastic. Good for you. But if you have to find answers between 0 and 2 pi, it's in your best interest to get it all as one fraction and then just use this idea of like adding this thing to the numerator until it, falls. Now I'm repeating myself. So if you need me to repeat myself, watch the video again. We'll do another example together, and I'm gonna do it in 2 parts again. So the first part, you're just gonna see me isolate and get the base answers. And part 2 of the video is me explaining this part again. So you can watch both or just one or whatever you think you need to do to get it figured out.